Hi everyone, let's talk about chemical equations and reactions. Today we're going to look at how to look at a chemical equation and tell what type it is. Alright, so what is a chemical reaction? Well, first of all, it's a process by which one substance is changed into a different substance. That's what a reaction is. A change must take place. A new substance must be formed. Okay. Well, you have to have an equation. Okay, and on this equation you have an arrow, and you have reactants on the left side and products on the right side. So reactants react to produce the products. An example of this would be if I had hydrogen gas plus oxygen gas and it makes water. That's what's happened up in the clouds to make rain. Right? I have my reactants. I have my things that I must include to produce the products. This is kind of like a recipe. Right? If you're talking about a recipe, you got like to make a cake. All right, you got sugar, flour, eggs, chocolate. All right, you put them all in a bowl. All right, you go through the process of cooking, and then boom, you got a cake. That's what a chemical equation is. It's a recipe on how to make compounds. Now, there's some extra things that go along with this. All right, our symbols that we use. All right, and we're going to rewrite our equation that we just looked at. So I got S that stands for solid, L stands for liquid, AQ stands for an aqueous solution, which means it's just dissolved in water, and then G for gas. So if I were to put these in for this equation, I would have this is a gas, this is a gas, and this is a liquid. Oh no, it's raining because hydrogen gas and oxygen gas mixed up in those clouds to make water. Alright, so these symbols are usually included in all chemical equations. Alright, and it's just so you know what to put in your recipe. Now, our main goal for today is to learn these different type of chemical equations. You got synthesis, decomposition, single replacement, double replacement, and combustion. So I have right here a little generic equation for each. So for synthesis, A plus B, making AB is to represent the general shape, I would say, or makeup of this reaction. So for synthesis, A plus B, these would be single elements. All right, and together they're going to make AB, which would be a compound. Okay, but I'm going to go through and break these up, into their individual parts, what to look for, how can you identify, because that's the key goal for today is can you identify these different types of chemical reactions. So first up is synthesis. All right, synthesis just means you are combining elements to make a compound, or combining smaller little compounds to make one big compound. Right, that's what synthesis means, combining things. Two or more substances react to form a single product. All right, and if you look at our practice ones right here, our generic equations, you'll see there is only one thing in the products. And that's what we're looking at with this what to look for section. All right, this is a little hint on how to identify one of these chemical equations. So two or more pieces on the left, that's the reactants, and one compound on the right, which is the products. So all you gotta do is look at it and go, oh, there's one thing in the products. It has to be a synthesis reaction. Our second type of reaction is decomposition. Decomposition means a breaking down of a substance, right? When things decompose, they rot. Right? If it's like food, it gets broken down into its individual compounds, and that's what decomposition reactions are. You start off with one complex thing, and it breaks down into multiple little pieces. All right, so the definition says a single reactant decomposes or breaks down into two or more products. Think of this as you were walking with like a big Lego castle, right? You got all those little pieces connected together, and then you trip down the stairs. Oh no, there goes the castle, and it falls on the ground and it busts into a million little pieces. That's a decomposition reaction. You start with just one compound. Okay, you only have one thing on the left hand side, and that's exactly what we're looking at for the what to look for. One compound on the left. And then multiple products are going to be made on the right hand side. Okay, so an example of this would be NaCl, salt. And it's going to break apart into Na, cations, and Cl, anions. Okay, so it started off like one thing, and that should be the biggest tell right there. One thing on the left, and it's going to break apart into its individual pieces. The next type of reaction that we're going to look at is single replacement. Single replacement acts just like the name implies. Single replacement means one thing is replaced. It's also called displacement by some people. It's when an ion of a compound replaces the partner it is bonded to. Okay? So you have a compound and then like a single thing, like a single ion. And right then it goes, I don't know. I think I'm going to switch partners and get rid of who I'm bonded with and connect to this single ion. And it happens. Okay? So an example of this would be like a bond between you and your cell phone carrier. So say you got Verizon. So you have a Verizon phone and you are you. That's the bond. All right, but then you look over and you see a deal from T-Mobile that looks a whole lot better. So you say, bye, Verizon, and then you now have a T-Mobile phone. You had one replacement. You switched your phone. That's what's happening right here. A compound, it's breaking apart and making one switch. Now, what to look for if you have a chemical equation is a compound and a single ion on the left, and it's making a compound, a new one, and a single ion on the right. Okay, so compound plus single thing, arrow, compound plus single thing. All right, that's the big thing for single replacement. Single replacement is often the harder one to pick out, I think. A lot of students usually have problems with that. You know what students don't have a problem with? It's double replacement. That's right, double replacement is usually a much longer equation, so it's easier to identify. And it's the same thing as single replacement, except it involves two compounds, and they both switch partners. All right, picture it like some kind of like salsa club, all right? And there's a couple over there dancing, and a couple over there dancing, and then the next song, they switch partners. Okay, both people switch. Now, this one is pretty easy to identify because there are two compounds on the left and two compounds on the right. So if I had, say, NaCl plus MgO, and they were to switch for some reason, I would get Na2O plus MgCl2, right? The Na and Cl said, I'm breaking apart, and we're going to go ahead and form a new compound with the other compound as it breaks apart. So what to look for? Two on the left, two compounds, and then two new compounds on the right. And the last one that we need to go over is combustion. Combustion's a fairly easy one to point out, all right, because it's very specific. You have some kind of compound starting off that begins with C. It's carbon junk, I call it. All right, it could be C2H3. Maybe it is CH12O2. All right, but it's some kind of compound that starts with carbon. Okay, and it reacts with oxygen gas, to produce carbon dioxide and water. All right, those are supposed to be subscripts, but we're going to just go with it. Okay, it is very specific reaction. It's an exothermic reaction. You usually have fire or a little explosion with a combustion reaction like what you have inside your car with gasoline. All right, so you have to have carbon junk, a compound that begins with C, plus oxygen gas, and it has to make CO2 and water. If you do not have that, it is not a combustion reaction. All right, look at the other ones. It has to have those specific things. So let's go look at some examples here. Okay, so let's begin with the first one. I have Cl2. It's a diatomic molecule, but it's just Cl. And then I got potassium iodide, which is a compound. All right, so I got a single thing plus a compound. And it's making a single thing plus a compound. We already can guess. I'm saying the word in it. It is a single replacement. All right, let's look up what's next. I got barium plus 8 sulfurs, and it makes barium sulfide. So I got an element plus sulfur, just sulfur, so element, single thing. Even though there's 8 of them, we're classifying it because it is just one element that makes that up. All right, and it's making a compound. Note, there is only one compound. So I'm having 2 things that are adding together to make one thing. We could guess that that is going to be synthesis. Okay, so let's keep our answers underlined. The next one, it looks like I have a compound plus a compound, and it's making a new compound plus new compound. All right, it looks like a couple people switched partners here, and it's a longer one that involves compound plus compound. So we know that this is a double replacement. All right, we're moving along. Okay, and then the fourth problem, I have a compound that is going to become a single thing plus a single thing. Oh, wait a minute. We already talked about this. We start with one thing, and it breaks apart into many. One thing breaking into many, it's a decomposition problem. And then the very last one. Okay. I see a compound that's starting with carbon. Uh-oh, what do you know? I got oxygen gas, and it's making CO2 and water. We talked about a very specific chemical equation that has carbon junk plus oxygen gas, and it's going to make CO2 and water. That's right, this is a combustion. So it's just a matter of looking at these equations and seeing which one of the 5 it matches up to. Look at the generic equations, look at what I give you in these equations, and you should get it just fine. All right, so a couple more to look at and work out. Maybe practice on your own and see if you could get them. Okay, got to fix my arrows in there. I don't know why those didn't show up. But just go ahead and work these out on your own. And I'll see you later.